In this lesson we're going to combine the chain and product rules, and you'll be able to differentiate pretty much any sort of function. So just a reminder of the rules of differentiation. So if we're adding or subtracting two functions, we add or subtract their derivatives. So in this simple example, to find this derivative, we'll just differentiate these terms individually. So 6x is the derivative of 3x squared, 7 is the derivative of 7x, and the derivative of 900, a constant, is just 0. So in example 1, even though it looks quite complex, we just hold to those same rules and combine our chain and product rules. So in the first example, to differentiate this, I see this as 1, 2, 3 separate functions, and I'll add or subtract their derivatives as we go on. So for the moment I'm just concentrating on this first term, and I'll write its derivative. So the x plus 4 is the inside function, so I'll multiply by the power, so 3 times 3 gives me 9. I'll still have my x plus 4 there, reduce its power by 1, and multiply by the derivative of the thing that was inside. Okay, and then I can differentiate this next term. So similar thing, multiply by the power, 5 times 4 is 20. Still have that same function inside, reduce the power by 1, and multiply by the derivative of 2x plus 1. Since there's a plus between these two functions, it means that I'll add in between here as well. And then the final term, minus 5x squared, I can differentiate that like normal. Okay, from here, I'll do these two derivatives. So the derivative of x plus 4 is just 1. The derivative of 2x plus 1 is 2. And I can do some simplifications. So I've got 9x plus 4 plus 40 2x plus 1 to the power 4 minus 10x. I'll just do a little expansion here so that we can simplify and collect like terms with the 10x on the end. I'll end up with negative x plus 36 plus 40 2x plus 1 to the power 4. And that's simplified. So there's nothing too scary, just use the rules as per usual. Okay, example 2, we need to combine the chain and product rule. So I'll note that this is u times v. So u is 8, 3x plus 4 all squared. V is x plus 7 to the power 4. So I need to find u dash and v dash. So the derivative of u and the derivative of v. Derivative of u will be 16, so 2 times 8, 16. 3x plus 4, reduce the power by 1, so it's just the power 1, and multiply by the derivative of what's inside here, which is just 3. So as you get more comfortable with these, not completely necessary that you write the ddx of 3x plus 4, but you can if you want. Looking at v dash, multiply by 4, reduce the power by 1, and multiply by the derivative of x plus 7, which is just 1. So I'll just tidy these up. 3 times 16 is 48. 3x plus 4. And v dash is just 4x plus 7 all cubed. Okay, so from here I can write my rule for the derivative. Y dash is u dash v plus u v dash. Okay, and from here I can substitute in all these values. So u dash was 48, 3x plus 4. V is x plus 7 to the power 4. U is 8 lots of 3x plus 4 squared. And v dash is 4 lots of x plus 7 all cubed. Okay, so that's all well and done. Okay, tick, I've differentiated it. Now I just need to simplify this expression. Okay, so I might just multiply these two numbers together in the first line. Okay, so the 8 times the 4 is 32. And then I'm looking to factorize these two terms. So I'm looking for the highest common factor. First thing I'll look at are these numbers and see what the highest common factor of 48 and 32 is. Okay, so you think, alright, 2 is definitely a factor, 4 is definitely a factor, so that means 8 is definitely a factor, and what about 16? Yep, that's a factor as well. Okay, so our highest common factor of those two will be 16. Okay, and then I'm looking at the 3x plus 4s. They exist in both columns. And I'm going to choose the lowest power. So I'll choose the one that just has a power 1. And then finally, the x plus 7s. They're common in both. So I'll choose, again, the lowest power between the two, which is 3. Okay, so that's my highest common factor. And then in a big set of brackets, probably bigger than that, we'll see, we'll write what we have left over in both of these terms. So in this first term, to get from 16 to 48, I need to multiply by 3. So I'll have a 3 there. The 3x plus 4 is already there, all good, but I need one more x plus 7. Okay, so that when you do this multiplication, I'll have 16 times 3 for my 48. My 3x plus 4 is there, okay, and x plus 7 cubed times x plus 7 gives me my x plus 7 to the power 4. Okay, so you just go term by term and figure out what do I need to put here so that when I multiply, I'll get the original term. Okay, in the second term, look at the numbers. 16, I need to multiply by 2. The 3x plus 4s, I've only got 1 as my highest common factor. I need 2, so I better multiply by another 1. And my x plus 7s, I've already got the right power there. Okay, so you can test the expansion if you want, but that is that line factorized. Can do a little bit more cleaning up. So my highest common factor will stay the same. Just inside these brackets, I'm going to do expansion. Okay, anything might think, oh, why am I expanding if I've already factorized? Because then in this final line, yep, it's almost over. I can collect like terms in here. So I really got 9x plus 29. Okay, and there's it completely simplified and factorized. Looks pretty neat. It's good to go. Okay, setting out is really key. Not even the best student would be able to go from here to here. Okay, it's just impossible. Alright, turning the page for one last example, which will be probably the hardest example you'll see in your exercises. So we've got another chain rule problem and product rule. I should say further product and chain rule examples. Okay, so since I've got something on the denominator, I need to first just modify this so that I don't have a denominator, because I only know how to do things that involve multiplication. So the 2x plus 1 will come up and have a negative power. So my function, this is u multiplied by v. And we'll just roll through the chain rule as per usual. Correction, through the product rule. So u is this function, and v is that function. So I need to differentiate u. 9 times 6 is 54. Reduce this power by 1 and multiply by the derivative of what's inside, which is just 1. So I'm a big boy now. I'm not going to write that in. No, I'm not going to write it in. As long as you don't mess it up, it's fine. For v dash, multiply by the power, so negative 4. I'm going to reduce this power by 1. Negative 4 down 1 is negative 5. And I'm going to multiply by the derivative of this inside function, which is 2. So my v dash is really negative 8 to x plus 1 to the power negative 5. Okay, so we've got negative powers all over the place, but we're not going to get scared. We're just going to apply our product rule as per usual. Okay, so I'm going to substitute in these 4 expressions. U dash 54 x plus 3 to the power 5. V is 2x plus 1 to the power minus 4. And then I'm going to add u multiplied by v dash. So since this is a minus 8, I'll just put a multiply sign in between it so I don't get confused later on and think that I'm actually subtracting 8. Alright, because I'm still a bit of a beginner, I'm going to invest one line of my solution in just multiplying these two numbers together. Okay, to get minus 72. Alright, between 54 and minus 72, you need to find what the highest common factor is. Alright, so between these two numbers, between 54 and minus 72, you need to put the highest common factor. Okay, it's going to be 18. And the way you can do that, 54 is like 2 times 27, which is 2 times 9 times 3. Or 2 times 3 times 3 times 3. And for 72, it's like 9 times 8, or 3 times 3 times 8 is what? 4 times 2. 4 is 2 times 2. And then we look at what we have common. So we've got a 2 common in both, and 2 3s common. Okay, so 2 times 3 is 18, highest common factor. Or you can just guess and check until you get there. Okay, so I've got my 18 there. Now I'll look at my other terms. I've got x plus 3s. Again, I'm going to choose the lowest power of these. So that'll be the power 5. Okay, and then finally I've got 2x plus 1s. Okay, so in here I'm going to choose the lowest power of these, which is minus 5. Hopefully you're whispering minus 5. Like, yeah, that's the lowest. Okay, then inside a big set of brackets, I'm going to write what I need to multiply this by to get the terms inside. So to get from 18 to 54, I need to multiply by 3. Okay, I've already got the right power of my x plus 3s. And I need to think, alright, 2x plus 1 to the power minus 5, I need to multiply it by 2x plus 1 to some power so that I can get 2x plus 1 to the power minus 4. So I need to have minus 5 plus something to get me minus 4. Okay, because when I multiply, I'm going to add these powers together. So that power is going to be 1. Okay, I don't have to write the 1 there. I can if I want, but I don't have to. Okay, so that's the first term done, and then look at the second term, 18 times something to get me 72. If you can't figure out what these are, just do 72 divided by 18, and it'll tell you what the number is. Okay, so I need a 4, but note that it's a negative, so negative 4. Look at my powers of x plus 3. I need 1 more to get from 5 to 6. And finally, my 2x plus 1 power is already correct. Okay, so I could bring that bracket back in a little bit. That's the hardest part, that factorization. Okay, now I'm good to play around with what's inside the brackets. Okay, so 6x plus 3 and minus 4x minus 12. Okay, so then it's just a case of collecting like terms in this last bracket, so 2x minus 9. Okay, and it's good to go. I get an A+ for that question because I've learned how to factorize and simplify well. So over the page, there's some questions. Okay, do a good sample of those, get some good practice in. Whole heap of questions and some solutions at the end as well. Okay, note that there's 2 question 5s.